A blessed day to each and everyone, and again, welcome to another session of professional development, which is all about probability. Let's begin. In here, we're going to discuss about the definition of probability. We're going to also talk about some formulas when it comes with the theories, and when are we going to use probability? What is probability? When we talk about probability, this is how we express a particular knowledge or our belief that a particular event will going to occur on a specific chance. And this is derived from the Latin word which means approval. And this is also based on observation to a series of events, and it is a branch of mathematics which we use in studying the patterns of chance. For example, we're going to measure on how likely it will going to occur in a series of events. Let's have an example of a coin. So a coin has two sides. It has the heads and the tail. So the chances of landing on the coins is 50%. Why? Because coins has two sides, and there is always a 50% chance that a coin will land on his tail and another 50% chance that a coin will lie on his heads. The formula for theoretical probability includes the probability, this is the event, the number of your favorable outcomes divided by the total number of outcomes. So E, we are defining this as the events. For experimental probability, this is a chance that is something will going to happen wherein your basis will be testing and observation of a result. So let's have an example of a dice. In this dice, it has 6 probability because when we roll a dice, so that we can able to get a 6, we have to roll it many times. Then after which we're going to divide how many times we rolled a dice with a 6 and how many times we rolled the dice in total. So let's remember, it's the probability is equals to event. That's the number of favorable outcomes divided by the total number of outcomes. Probability, when question arises which related to a chance of something is happening, we are dealing with probability. These are the common terms that we have. We have experiment. When we talk about experiment, this is a particular event wherein it always leads to an outcomes. And if there is an outcome, then outcome is the result which is based from the experiment. And outcome has a classification wherein we call it as equally likely outcomes, wherein all the outcomes are of equal probability. Let's also have the sample space. The sample space is the set of outcomes of an experiment. So whatever the outcome, then we can classify it as a sample space. For event, this is one or more outcomes in an experiment. And the sample point, this is the element of the sample space. So we are deriving the sample point to the sample space. Let's remember that probability is equal to the number of times of our desired outcomes that occurs divided by the total number of trials. These events are independent if our outcome of one event will not going to influence the outcome of the other event. So we have an additional rule wherein probability A or B is equals to probability A multiplied by P multiplied by A plus P multiplied by B minus P open parenthesis A and B close parenthesis, wherein we can say that according to this formula that the events are mutually exclusive since these events cannot be together. For instance, we have probability A versus B. So in this probability, if our probability A is greater than probability B, of course, we can assume that A is likely to occur. And if probability is A is equal to probability B, then we can say that probability is AB, which in A and B are likely to occur. And the type of events that we have sample event. Here, if there is an event that only has one sample and we have a sample space out as the outcome, we call this as elementary. We call a compound event if the event has more than one sample point. Here, we will be talking with mutually exclusive events. In mutually exclusive events, we have two events that are mutually exclusive events if the occurrence of any one of them excludes the occurrence of the other. So example, here we can say that we have a set A and set B. In set A, we have 1, 3, and 5. And in set B, we have 2, 4, and 6. So we can say that these are mutually exclusive events because they are not happening at the same time. So A and B, therefore, are mutually exclusive events. And this can be represented by the following formula. So A are mutually exclusive, A and B are mutually exclusive events for the probability. This we're going to talk about and emphasize that mutually exclusive events here are pertaining with sets. We also have exhaustive events. Here, we can say that E1, E2, En are n events of sample space. And if we can say that E1, E2, E3, En is equals to Ei is equals to S. Here, we can say they are in exhaustive events because E1 and E2 and En are called exhaustive if at least one of them necessarily occurs when an experiment is being performed. So, let's take a look of the spinner. So, this spinner has 4 sides. So, it has colored yellow, blue, green, and red. So, suppose we're going to spin this on the spinner and it had been landed on the red color. Now, what types of outcomes are we going to expect on this event? Here, we can say that the chances of landing on the red is 1/4. Why? Because red is only 1 and we have 4 colors on the event. So, we might say that these chances are so because our spinner is divided into 4 and it landed on one of the equal sides. For example, the dice. The probability of the dice is 1/6 because we can say that if we pick number 1 for the dice, then the dice has 6 numbers, so that's 1/6. Because each number has 1 to 6, we can say that those numbers are 1, 2, 3, 4, 5, and 6. We have 6 total number of dice. So the probability of even number, if we're going to take a look, we have the even number of 2, 4, and 6. So they are 3, and the total number of the dice is 6. So that will be 3/6, and then 3 divided by 3 is 1. 3 divided by 6 is 3. Or we can say that it is 1/3. This is also the same with odd numbers because we have the odd number 1, 3, and 5. So there are 3 odd numbers divided by the 6 total number of dice. And then 3 divided by 3 is equals to 1. And 6 divided by 3, that will be 3 or 1/3. Let's remember this rule that the probability of an impossible set is 0. If we got 0 from our calculation, then that's impossible probability. And probability is always between numbers 0 and 1. And all the sum of our probabilities of all possible outcomes, we can see that in a sample space of 1. And the probability that an event does not occur is 1 minus the probability that it does occur. And we call this as complement of A as well. And if we are going to get 1, then that is the probability of sure event. These are the possible outcomes and counting techniques. So if we're going to take a look, we can do one task in A always and second task in B ways. So both tasks can be done in A times B ways. Here, we're going to flip coin and toss it a die. So that will be 2 multiplied by 6, that's 12. 12 is the possible outcome. So we flip the coin 2 times and then the possible outcomes is 6. So 2 times 6 is equals to 12. Here, we can see the diagram of a flip a coin and toss a die. So if we're going to flip a coin, so we have a head and a tail and then we toss it 2 times and on that 2 times we have 6 possible outcomes. Okay, that's the H1, H2, H3, H4, H5, H6. So toss a die, that's toss 1, 2, 3, toss 4, toss 5, and toss 6. We are using probability always in our daily life, and it is used in mathematics, science, finance, even in gambling, in mathematics and artificial intelligence. Let's have this example from YouTube. So here, we're going to find the probability of a marble from a bag with 3 yellow, 2 red, and 2 green, and 1 blue. So here, we're going to pick the yellow marble. So our probability here will be picking the yellow marble. So here, we have the yellow marble is 3. So this, we're going to satisfy our constraint. And if we're going to add all of this, 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 1 is 8. So divided by 8. So 3 divided by 8. Why it is 8? Because we have 3 yellow, 2 red, 2 green, and 1 blue. So 3 divided by 8. So our answer will be our probability. So that's just it for today. And these are some of the examples of the questions if you want to get the following probability. Thank you, and see you again on my next vlog. Bye!